So today we're going to ask the question, what tracks molecules to each other? And you might guess that this might have some things to do with melting and boiling points. And we probably remember that way back in honors chemistry that ionic compounds tend to have higher intermolecular forces because their attraction is totally ionic, and so their melting point and boiling points tend to be high. However, molecules that are molecular, molecules like, CH4, or even molecules like molecular, diatomic molecules like H2, they tend to have melting points and boiling points that are really low. And that means that these kind of molecules that are, molecular force, they tend to be gases at room temperature. Whereas molecules that have high intermolecular forces tend to be solids or liquids at room temperature. That the same temperature that molecules with smaller intermolecular forces might have. Let's take a look, as we're going to break some of these up into some different categories here. Obviously, the ones that are strongest, what we'll call moderate. None of these are on the order of ionic compounds, but we might have situations where you have an ion, like, for example, say sodium, something with an obvious charge that is attracted to a molecule with a strong dipole, for example, like water. Also, hydrogen bonding, and let's remember that this is particular to ions or compounds, that have a hydrogen attached, our old buddy water. And remember that water is a strongly polar molecule with a very defined negative side and a very defined positive side. What makes it strong is that, first off, these bonds are extremely polar because there's a large difference in electronegativity. And secondly, the hydrogen atom is very small. Because hydrogen is so small, it permits very tight tolerances. It allows for close contact. And because it allows for such close contact, the closer they get, the stronger the attraction. As opposed to molecules that don't have this kind of attraction, we have something where we'll have a situation between two polar molecules, and that is fairly strong compared to, or fairly weak compared to ion dipole forces or a hydrogen bonding, which of course is much weaker than ionic bonding. And even wimpier is this, what we call London dispersion forces. Collectively, these are called van der Waals forces. And this occurs between all molecules, and it even occurs with single atoms. And what we want to pay attention to here is that the strength of this London dispersion depends on size and polarizability. And that means that molecules that are large have much greater flexibility in how their electrons can get smushed around. Even single atoms do it, but very little. The larger the molecule, or the larger its polarizability, the greater the chance of its intermolecular forces being larger. So we'll say that this is very large, and of course it's relatively speaking. All right, take this for a spin, and I'll see you guys later on.